All righty. Well, thanks to everybody who's joining us today. We're really happy to be here. We've had a couple of technical glitches, but I think we're past them. So welcome to Rivers and Migrating Fish right here on Earth Day. Awesome. So we're going to be talking today about migrating fish, specifically river herring. It's a spring migration that's invisible or largely invisible. It's really exciting to be able to share awesome spring event with you today. My name is Marian Miller. I am the watershed educator with Mystic River Watershed Association, and I'm happy to be here with a team of people who know more than a little bit about river herring. So today you'll find out a little bit about the Mystic River if you don't already know, and you'll find out a lot about river herring, which are the cutest, most remarkable little, well, not that little, sort of smallish fish, and sort of their amazing life, which honestly I never knew anything about before I started working here. So that's me. I'm going to pass it off to Meghna to introduce herself.
Hi, I'm Meghna Marjati. I'm a PhD candidate at UMass Amherst, and I study river herring life cycles. And I'm excited to share some information about that with you today.
Andy.
Hi, I'm Andy Frisetta. I'm watershed scientist at the Mystic River Watershed Association, and I'm excited to share with you the story of a really great ecological restoration story on the Mystic.
Thanks, Andy and Meghna. We're also joined by our colleague Elo, who's holding down the fort behind the scenes. So he may make an appearance at some point, which would be awesome. He's going to help manage the question and answer section and also post some resources. So we will be using the chat feature for questions. I think the way we're going to do this is do this presentation, tell you a little bit about the river and a lot about the river herring, and we will leave time at the end for questions and answers. So I bet you'll have some questions and put them in the chat and we'll get to them. We are also not joined currently by one of our volunteer herring counters because she's stuck out at Horn Pond where she was counting river herring. She sent a couple pictures that maybe I'll be able to share with you, but her car is incapacitated and she's waiting for roadside assistance, I think. So Danny may or may not join us, but let's get started. I wanted to just share a little bit about the Mystic River, and then I'm going to pass it off about herring. So let's see. So again, there's the Mystic River. If you don't know the Mystic River, you are so not alone. So many people that live in the Boston area know the Charles River, but not the Mystic River. The Mystic River is a beautiful river in a lot of places, and it's an important river for us. So here is a view of the Mystic in Medford and Somerville. And if you look closely, you'll see the Boston skyline. And I wanted to show you a different view, which maybe I'm not going to, there it is. Okay, so the Mystic River is not a really long river. It's only 7 miles and it is in a very densely populated, let's see if this is going to work, watershed. We're the most densely populated watershed in New England. And I'm just going to see if I can zoom us out. These are our offices right over here. So I thought I'd start us in Arlington and then see if we can find the Mystic. So I would also invite you guys in the Q&A to say who you are and where you are so that we have a sense of who our participants are. So please introduce yourself while I'm trying to zoom in and out in the Q&A. So I'm seeing a water body here. This is the lower Mystic Lakes in Arlington and Medford, and that's going to be really important to our river herring story. And here's the beginning of our river right here, Mystic River. Let me zoom out a bit and see if we can see where the river is headed. So right here is its beginning, and it makes its way down towards Boston Harbor, which I'm hoping I'll be able to show you. Let's see. There are a few tributaries that come into the Mystic River, and it empties into Boston Harbor here. So if you live in the Boston area and you're familiar with the Boston area, you know this river, the Charles River. The Mystic and the Charles come into the Boston Harbor at about that same place. And the Boston Harbor, I'm sure you know, connects to the outer harbor, which connects right to the Atlantic Ocean. So that gives you some orientation, and it also sort of is, all this information is important to our story of river herring. So I am going to stop my share and pass it over to Magna.
Hi, so we are going to air a video about the river herring life cycle. That is a collaboration between a couple of friends and I, Vivek and Shahjahan and Sohini. And this was kind of birthed out of, we met up at a local open mic called Subject, which is an open mic for South Asian, people of South Asian descent in the area, and has a lot of different art that's offered. And just decided to explore my research through art and dance. So I'm going to share a video with you. I'm going to share the sound as well. And we hope you like it.
On a calm summer day in the depths of the Mystic Lake, after a massive mating party, Glitter hatched from her egg on June 23rd, 3 to 5 years ago. She hatched among her other friends, Sparkles, Zimber, and Tinsel, and they absorbed their glutinous jelly shells. The four became lifelong friends after meeting while eating their favorite small water bugs, which scientists call zooplankton. Hello? Can I share some of your bosmina? Sure, I brought copepods. Yay, crunchy! I love a good exoskeleton. The fish liked all of the big, yummy zooplankton. They ate so many of them that only the small ones were left, and they just didn't taste as good. The fish also grew. A lot. Eventually, the four friends began making plans to leave their home pond to get to the ocean. Sometime between June and January, Sparkles, Glitter, Tinsel, and Zimber joined all the other juvenile fish to start swimming downstream to the ocean to begin building their lives as adult fish. We don't actually know when or why juveniles leave their ponds. It could be because of water temperature, moon cycles, flow rates, or changes in food availability. This is where my research comes in. My scientist friends and I are trying to figure out why fish leave the pond and how their timing might be influenced by climate change. For example, if rainfall changes, that might affect when the fish migrate, and they could get to the ocean at the wrong time and miss out on getting all that good zooplankton. On their way to the ocean, river herring have a lot to do. They have to escape numerous predators, adapt to changes in water composition, and get past other obstacles. Oh, here's a predator now. Swim away, Sparkles! River herring are like the potato chip of the ocean, but more nutritious. This means most larger fish in the ocean are pretty happy to eat an alewife. Before entering into the ocean, Glitter and her friends also had to get used to salt water in something called an estuary, which is a part of the river where saltwater and freshwater mix. We're not sure how long fish spend in estuaries. This is something else. After many, our heroes entered the ocean. There, they spent 3 to 5 years becoming mature, adult alewives. We don't know where they go in the ocean while they are maturing, but we're trying to figure it out. In the ocean, there were lots of predators trying to eat them, including salmon, cod, otters, and seals. As they grew older, they had to escape these predators too, until 3 to 5 years later. Now that they were all grown up, it was time to return to their home ponds so they could have their own babies. So they decided to join this spring's annual alewife migration to the Mystic Lake. As adults, river herring returned to the ponds where they were born to settle down and have babies. We don't quite know how they find their way, but often dams and other human obstacles prevent them from reaching their homes. And if they can't get home to have more babies, there won't be as many river herring. Did you know river herring populations have declined nearly 99% over the last 100 years, partly because of dams and other obstacles. Luckily, there is something called a fish ladder. There's one at the Mystic Lakes Dam, which helped our heroes get upstream. And luckily, they got there at the right time. If they had come too early or too late, there may not be enough zooplankton for their babies to eat, or the water may be too warm or too cold. Finally, after traveling hundreds of miles and facing predators, dams, and other dangers, Sparkles, Glitter, Zimber, and Tinsel made it back to the Mystic Lake to have a disco spawning party. Spawning is how fish mate. This is when the female releases eggs and the male releases his sperm over the eggs. The sperm and the egg make a new baby fish. Once they're done mating, our heroes will start their journey to the ocean, where they will stay for a few years. Sometime in the summer, the baby fish will hatch, and the whole epic journey will start again.
So that's all of our video, just introducing us to the river herring life cycle. And I guess I'll pass it off to Andy, who's going to tell us a little bit more about what specifically the river herring and the Mystic River watershed are doing.
Oh my gosh, that was fantastic. I hadn't seen that before, and so I just love it. And there's like literally no way I can follow that, but I'm gonna follow it anyway with my very conventional slideshow presentation. But let me go to that. Hold on one second. Yes, so one second. Great. So welcome everyone. And yeah, so I'm going to tell, so that was a fantastic introduction to the life cycle and the migratory journey of these species. And there are two, alewife and blueback herring, and Alewife Brook is one of the major tributaries to the Mystic River, just to tie these pieces together a little bit. But I want to show what happened. So on the Mystic River, we built one of those, we collectively, communities around the watershed built a fish, and the state built a fish ladder at a key location. And I'm going to show you what happened when that was put in. And sort of background, again, this is a slide that Magna showed that shows this, you know, huge drop off, even since 1970 this is fish catch data, so it's not directly population data, but huge crash in the population of these fish. One key reason is over-harvesting in the ocean. We just got super effective, super efficient at catching fish, and the populations crashed. But another threat, as Magna mentioned, to these populations is the existence of dams. If they can't get to those inland freshwater lakes and rivers to spawn in, they can't reproduce, and their populations can't grow. And so as we're concerned about recovering these populations, it's important to get those fish, the fish that are returning to our rivers, past the dam obstructions and into as much habitat as they can. And this is a kind of very complex graph, but it shows the many, many dams put in between 1630, the first dam on the Charles River in Watertown, to 1900, all through New England. And all of these are collectively blocking freshwater habitat from river herring, and these graphs show the decline over time in freshwater habitat. So anyway, that's sort of the background. Zooming into the Mystic River, there are 4 dams that play a role in our story. The biggest dam on our river is the Amelia Earhart Dam at Assembly Row in Somerville, that separates what's now a freshwater section of the river upstream from the downstream saltwater section. Before this was put in the 1960s, this whole river system used to be a tidal system. So when the tide came in, the water level would go up, and when the tide went out, the water level would go down. And there was salt marsh in Malden, and there was, you know, this was all salt marsh habitat in the 19th century, and this went, and even into the 20th century, this was a tidal river. So, but it now blocks the tide. The tide goes up and down 10 or 12 feet on this side of the river, on this side of the dam, and then the water level stays quite stable here. There's a similar dam on the Charles River in Boston. In any case, you might think, so this is a huge dam, it changes the flow of the river hugely, but it's not really the river herring's main obstacle, because it opens very frequently. So it opens every 12 hours, essentially, to let water out. And this is surprisingly transparent to fish. Like, fish can get through this dam. Because of the way the locks work and the way the gates work, they can get through this dam. But it turns out there's a small dam up here, relatively small compared to that, at Upper Mystic Lake, that turned out to be the real central part of our story. So this was put in the 19th century. So for over 100 years, more or less, migrating river herring could get up the Mystic River, and they're looking to spread out, right? So you imagine many, many fish coming in, and they want to spread out as to get as much space as possible for their offspring to catch food, the zooplankton that Magna mentioned. So they try to get as far upstream as they can. And they were blocked here. So they would only be able to use this part of the river and the lower Mystic Lake for a long time. And so the question is, how do we get fish past that obstruction of the Upper Mystic Lake Dam? And in a kind of fun piece of history, before the fish ladder was put in, our organization helped with the so-called bucket brigade, we would literally get volunteers, including kids, and the fish are swimming upstream. So from the right of this screen to the left, you can see the water flowing down from the upper lake to the lower lake. But they can't get over this obstruction. This is too high for them to get over. So they congregate here trying to get upstream, and people would, including kids, catch fish in nets, put them in buckets, and literally haul the bucket up to the top and pour them into Upper Mystic Lake, kind of bucket by bucket. This turns out not to be an efficient way to get hundreds of thousands of fish into a lake. So in 2012, the efficient and kind of permanent solution was put in at that point. And this is the fish ladder. On the left is showing the structure when water isn't flowing down. So we're at the bottom of the screen, you're at the top of the dam looking down toward the lower lake. And on the right-hand side, it shows what it looks like when water is allowed to flow down this structure. And it creates these little pools. And each of these little steps, so-called steps on this ladder, create a little pool of water at each kind of a vertical line here. And so fish can jump up from or swim upstream, swim up over the 1 foot obstacle and kind of rest here if they need to or keep going. And so this allows fish to get from this bottom lake up 15 feet or so to the upper lake. So, whoops. So what is that? So the way I like to think about this is that we conducted, as a kind of community, a kind of natural experiment on a big scale. Before 2012, the fish that returned to the river, and as I'm sure Meghna mentioned, but it's worth repeating, they returned to the river they were born in, amazingly, with a lot of fidelity. So the fish that were born in the Mystic River system would come back, and this was the only area they had for breeding before 2012. After 2012, the area for breeding was expanded to include this very big and high quality lake for them to breed in. So we have a population of fish coming back to our river of a certain size. What happens if you give them access to new kind of underused breeding habitat? So that's the experiment, and here are the results. And so this is really a kind of remarkable thing, and we were so excited when we saw this. So I should add that the reason we have these numbers is that there is a volunteer counting program where we assemble volunteers, and they go every hour from essentially every daylight hour from April to June, and stand at the dam and count for 10 minutes and say how many fish do they see going from the lower lake to the upper lake. And those samples are put into a model, and we estimate, or the Division of Marine Fisheries estimates a total fish run. And you can see that over this time period, the population more than doubled, even tripled between 2012 and 2019. And Meghna mentioned that the birthday party the fish had at age 3 and 4. So notice that the first 3 years, in the first year, we estimated the total run was 200,000 fish past the dam. They went over the fish ladder. In the next year, 200,000 fish went over the fish ladder. And the third year, 200,000 fish went. So we're like, oh, did it work? Did it have any effect? Did it result in a bigger population of river herring? They now have that lake. They've had that lake for 3 years, but the count seems to be the same. But the key fact here, and this really kind of blew my mind when I saw this, right, is that the new fish that would have been born, the so-called new fish, the extra new larger population of juveniles that would have been born in 2012, don't come back the first year. They don't come back the second year. You wouldn't even see the signal in the 3rd year. Where you would expect to see the signal is in the 4th year. And there was this beautiful doubling. And everyone who looks, all the fish scientists who look at this story say, yes, by building that fish ladder, which is a pretty cheap intervention, we effectively tripled the population of fish, now approaching 750,000 fish. I like to say that if they're about, they could be a foot long, that would be more than 100 miles of fish end to end in a 7-mile river system, or 15-mile river system. And really extraordinary success story. So we as a community did an experiment and it worked and the result was that we tripled the population. And again, in the most urbanized, most densely populated by people watershed in New England. I asked, so, when these 700,000, there's probably 600,000 people in our watershed, there are now officially more adult river herring in our watershed than there are people. And if you count juvenile herrings, it was for the period that the juveniles are in the water, this may be the most populous, numerous vertebrate species in our watershed when they're here. So it's a fantastic story. And then that would have been a perfect story, tripling, the line is going up, everything is great. We counted last year. There's some special things to say about last year because we didn't have the COVID interfered with certain kinds of sampling, but it looks like the population went down last year. And I just wanted, because we have this data, I wanted to share it. It complicates the story here a little bit, but it now looks like the population went down. So what happened? I'll ask you to remember that fish return at age 3 and 4. So if you look at 2020, you might say, okay, what happened 3 or 4 years earlier than that might explain this population change? And in fact, in 2016, there was a severe drought in Massachusetts. And it extended into the fall emigration period when the juveniles are trying to get out into the ocean. It affected water temperatures. It probably affected the populations of the things that fish eat, and it affected population, the conditions for juvenile development and all sorts of things by raising the water temperature. So there are many possible ways that the drought could, and it can dry, this doesn't apply so much in our system, but it can literally dry up the streams that fish would need to get back to the ocean. And that happened in Eastern Massachusetts. So this is a possible explanation for what happened. It's in fact a likely one. This is another map that just shows in the fall, severe drought conditions in Eastern Massachusetts. And more evidence that this is what happened is that it happened not only in the Mystic system, but all around the state. So in 2020, the counts across the state, including these big runs on the Cape, had big reductions in the populations of fish returning. And so we think this is, or scientists think this is the result of that drought. And what's cool about this, and because we still have the counting in place, we expect the population to go up this year again, because the next year was not a drought year. And so we'll see if that happens. It's really exciting and really look forward to it. So what's next? The next big lake in our system is Horn Pond. The fish ladder was put here at Center Falls in Winchester, and federal money is now coming to Horn Pond to build a fish ladder here. And these are fish gathered at the bottom of this dam at Horn Pond. They can't get over here. They can't get over this obstruction, but by 2024, on the scale of millions of dollars of funding is coming to build a fish ladder there. And that'll be another opportunity to expand the population and expand breeding habitat. So that is our story. I never tire of telling it. Thank you for listening, and thank you very much.
Great, thanks, Andy, and thanks for the video, Magna. That was great. So the story of river herring is both complicated and fascinating to me, and I hope that you are all finding it interesting too. I had a question I saw in the chat that maybe I'll ask right now, because maybe it helps with some of the other story. One of the questions was, how do fish know the route? How do they know? So I'm wondering if either Magna or Andy could field that one right now before I move on.
So it's not what I look at specifically, but from what I understand, it's similar to salmon. They use microchemical signals in the water to figure out where they're going. But it's also definitely a subject of active research. It's not something that has been fully understood. Like in the video, we don't totally know the migration patterns of these fish, and to the point where I'll talk about it a little later, but one of the things we're working on in general is figuring out where they even go in estuaries and trying to tag them and stuff. So very good question. We do know, the reason that we know that they go back to their birth ponds is using genetic data. So we're able to do genetic panels to figure out that certain populations and different watersheds have genetic signatures that are unique. And so that's how we know they go back to the same place. How they figured out, though, is a different story.
Great, thanks, Magna. Andy, was there anything you wanted to add, or?
Oh no, I defer completely to Magna's expertise here.
All right, sounds great, thank you. Well, we were expecting to have one of our fish counters join us today. Again, as I said, she's had car trouble, so she won't be. But Andy had graphs of herring counts, and that's kind of an interesting thing to me. Like, how do we know that? We know that because there's actually a protocol that is counting fish. We have a way to do that. We were hoping to have one of our volunteers talk to us about it, but I'm wondering, Andy, if maybe you could talk just quickly about our protocols and how we know the numbers. How do we do that?
Yes, sure. So, you know, one way to, the way I kind of think about it is that one way to count the number of fish that are going from the bottom lake to the top lake would be to just stand and watch all the time, 24 hours a day, and just from April to June, and just count the number of fish. But that's not a practical way to do it. Like, we can't, or efficient way to do that. So what we do is something that's pretty extraordinary, which is gather, and this happens all around Massachusetts, gather volunteers who come and say, I can't count all day, but I can count for 10 minutes. And so we divide the day from 7 a.m. to 7 p.m. And this is done with these protocols from the Division of Marine Fisheries. And people say, okay, on Tuesday between 11 and 12, I can count for 10 minutes. That's a commitment I can make. And so we have, so, you know, it's 12 slots per day times 7 days a week. That's 84 slots a week. So we have 84 volunteers who come to the dam and count for 10 minutes. So we don't have the whole hour, but we have 10 minutes. So you can think of it as a kind of random sample from that hour. And you can say, okay, in that 10 minutes, and here I'm simplifying a bit, but the statistics get complicated quickly, but there's, you know, 100 fish came by in that 10 minutes. So if I had to guess how, you know, just, I think of it, how would you do it intuitively? They're coming at the rate of 100 every 10 minutes. So I would guess, you know, 600 plus or minus came in this hour based on what I saw in that 10 minutes. Anyway, so if you think about all these samples, they get plugged into a sophisticated, you know, statistical model that says, we have experience in this domain, and we know what how to correlate counts from samples with estimates of total populations. And so we send those just 10-minute counts to the Division of Marine Fisheries, and they return a number that says, okay, based on that, we think that if you were there the whole time counting, you would have seen 200,000 fish plus or minus 30,000 fish. There's a margin of error. And so, but just intuitively, that's how the system works.
Great, thanks, Andy. Not to put you on the spot, Magna, but I have learned that you helped to set up this protocol for us a while ago. Is there anything you would like to add?
I think that pretty much covers it. The model that's used is based on previous counts, and so it just accounts for different statistical sampling. It's designed by the Marine Fisheries Division.
Great, thank you. Well, I noticed in the chat that one of our counters is also on this webinar, and so maybe there'll be a few more details about volunteering to count. So we're counting at Mystic Lakes now at the dam there, as Andy referenced, and also at Horn Pond. We use little click counters. So click, click, click. When I've been at the dam on days where the herring run is very big, so many fish coming through, I marvel at how our volunteers can get a count when there seem to be literally hundreds of fish coming through. But some of them have said to me, well, you just do it for long enough that you figure out how to sort of group them together like groups of 10 and counting. So thanks to our really smart volunteers and for coming out and helping us to know this data. It's really great. The other thing I wanted to say, and I don't know if any of us mentioned it yet, but I don't think the herring are running yet. Am I correct? It's a spring migration, but it's still a little early.
I think that's right. I think we have not seen our first report of a fish yet in the Mystic system. It's a little bit early.
But it's coming.
But by early May, they're coming in good numbers. Yep.
Okay.
Weymouth. I heard from somebody that there's some river herring in Weymouth.
Oh.
Yes, and I saw on Twitter that there are river herring in the Herring River, but I think it's early. I think they go to the Cape earlier than they come. They happen to make their way to Upper Mystic Lake.
Great. Okay. So in addition to our actual in-person volunteer counters, we also are gathering data in another way. And I am hoping I can share what that other way is. And that other way could involve you all. Let's see if I can get to where I want to be. Maybe not. Let me stop this for a minute. We have an online herring cam that is at Mystic Lakes. I guess, Andy, it was installed when the fish ladder went in. Is that correct?
No, it was installed fairly recently, like 2017, I believe.
Oh, okay. All right. So my error there. I'm trying to get to, let's see, am I gonna be able to get to this? Maybe yes and maybe no. I'm linked right to the internet. Okay. Well, you guys are gonna have to bear with me for a minute unless, let's see, Andy can pull it up, but maybe not.
I could try. Would you like me to try?
Well, I might have just figured it out, Andy. Hold on a minute. Just a second. I almost have it. I decided to embed my links in my PowerPoint because I had a near miss on Monday. So I'm also having a near miss today. Okay, so let's see if I can get to, there it is. So I think these fish are adorable. I love them. They are so cute. And honestly, I'm not a fish person. I don't say fish are cute generally, but these are awesome guys. So let me see if I can send us. All right, we got it. So the website is mysticherring.org, and there is a way to count fish. Love nature. It's Earth Day, you guys. Love nature.
Marian, excuse me. We're still seeing your PowerPoint.
Oh no, we didn't get taken. Thank you for telling me.
You're welcome.
Andy, maybe you could pull it up on yours since I seem to be.
Let me try. Let me try. 1 second.
Since I seem to be failing.
Yes. Let's see if I go to, nope, go to not the Washington Post, but to this website. Can you see this screen?
Yes,
Love Herring. Yep.
yes,
And
great.
so, yep, great.
Okay, so I guess you just now became the demo person
Okay.
because you have control of the screen, if that's okay.
Okay, that's fine. This is the home screen of our counting system. So let's see if I can explain this quickly. There's a camera that's at the top of the dam, and it's pointed in such a way that you can get another view, a kind of side view of the fish that are entering from the lower lake into the upper lake. And if you hit start counting here, ignore this warning message. It's just about that the season hasn't started yet this year. And this is last year's video data, but whenever the camera is pointed across the stream here, so water's flowing from the left to the right here, and then to the right is the fish ladder going down to the lower lower lake. It's set up so that it's sort of motion detection activated. So when a fish comes by, it's set up to record a video up to a minute long. And if fish are still coming by, it keeps recording 1 minute videos. And then it stores them in a kind of archive, but it also records them as a record in a database. And so we can now, there's this beautiful system designed by a hydrologist, data scientist who we work with, who's a brilliant guy. And it allows you it serves up a video here for you to look at. For instance, I'll hit play here and we'll see a video, hopefully, of a fish going by. Sometimes there are videos when the light is fluctuating like this, when there are 0 fish, just because it can't quite tell that light fluctuation wasn't a fish. But let me just try this again. But it allows you to enter a count, and in this case, I will put 0 because that's what it said. And now that count of 0, it thanks you for submitting that count, is literally attached to that video record in a database. And so this is a different way of sampling all the fish that are coming by. I've made an estimate of how many fish were coming by in that 30 seconds or whatever it was. And now all that data is collected, and you see there's not much activity yet because the season hasn't really started, but this is last year's data. And it takes all the system, there's another model that's taking this video data and saying, okay, here are all the samples I have. I know there's thousands of videos. I only have a subset of samples. What's my estimate for how many total fish actually came by based on that sample? And this is the estimate. And so this is last year's data. And you can see on busy days, 40,000 fish came through. On quiet days, 50 fish came through. And they come in these pulses over the season. This is early May to June. May is really the peak season for our fish. We also have water quality information and the number of fish counted information and stuff like that. Let's just watch one more video here. Oh, sorry. This one may also be 0. This is not typical of the view you get when they're coming very fast. Let me just quickly show you here. This is a video, the same view of a day when the fish are flying through. And again, these are fish. This is real time speed. It's not sped up at all. This is just fish flying through. They've come up that ladder many steps. And this is the final step into Upper Mystic Lake. So sometimes, in a minute, 400 fish go by, and sometimes 0, as you saw, and sometimes 10 or 20. In any case, the website, which I'll just quickly go back to here, allows anyone to participate in this estimate of the total population. This is kind of a parallel study. And there's a leaderboard where you can compete for the top number of videos counted. Some people just put crazy amount of effort in last year, and anyway, yeah, so we really encourage folks to engage with this tool.
Great. Thanks, Andy. Absolutely. So the fish aren't here yet, but they're close by and they're on their way. So we'd love your help counting fish when the fish arrive. But right now, even today, check out this website, count some, practice. Again, 0 is an important number. If you see no fish, please put that down. That data that helps us out. It's kind of cool to see the fish coming through and to be able to participate in this community science project. So please check out the website. There's information about river herring in case you're curious about river herring. There's more information. There's a section for students in case that's useful. We do education programs for communities throughout the watershed. So, you know, that's a thing too. Before we move on to kind of our final part, which I'm calling the importance of herring to the ecosystem, I thought maybe we could do a couple of questions. I know, Magna, thank you. You've answered questions in the chat and in the Q&A. I appreciate that. People are asking questions, but in case nobody, or in case not everybody has accessed those, maybe, Magna, maybe you could share one of the questions. Would you be willing to share a Q&A that was interesting to you from the chat?
Sure. So one of the questions was whether or not we can use a drone to count the fish. And underwater, so I guess we would be thinking about an underwater drone. Putting an underwater drone in for like the whole period of time of migration is about 3 months. And so it's a lot of video footage. Somebody would still have to review that. So even keeping the camera in there, reviewing that footage is difficult. But I am working on an emigration camera that's in another location, looking at counting baby juvenile fish as they're leaving freshwater to go to the ocean. And we have initial opportunities to use an algorithm that can count river herring, but it's still something that's really difficult to use. So not really as possible as you would think yet. Another question was, what are the ecosystem and other benefits of increasing the river herring population? So we're mostly restoring it rather than increasing it. And river herring are food source to like a lot of other fishes and animals, otters, salmon, cod, stuff that we eat. And then additionally, they transport important nutrients from the ocean to freshwater and from freshwater to
Great, thanks. Our colleague Elo just posted some links in the chat, and maybe Elo, there's a question you found interesting that we should answer live. Not to put you on the spot, and you're invisible.
I think that's the best thing, being invisible right now behind the screen. But honestly, I've been enjoying you three cover all this. But I did have the drone question, definitely I was curious about. So thank you for just answering all that. But I'm gonna swing it to Andy because I feel like Andy has something to say.
Oh, thank you. No, a kind of fun fact that I often share that also kind of surprised me and makes these fish seem extra special is that, you know, this behavior of going from saltwater to freshwater to spawn, or conversely to go from freshwater where you live most of your life to saltwater to spawn, is actually a very rare thing among fish. You take the average saltwater fish and put it in a lake and it will not thrive. And it turns out that fewer than 1% of fish species, total fish species in the world, 1% show this behavior of moving back between these two habitats. So that just makes our fish extra special in my mind.
Great, thanks, Andy. All right, so participants, anybody on this webinar, check out the chat and the Q&A because I think there's some interesting information there. I wanted to share not just fish stuff, but river herring are important to the ecosystem because they are food for so many things. So let me see if I can share some stuff with you. So these are bird sounds I equate with the ocean, right? Herring gull calls. But when the river herring are running, herring gulls are definitely heard throughout the watershed. At Mystic Lakes Dam in particular, it is so loud because the herring gulls are there for dinner, basically. And interesting, a number of organisms have names that tell you a little bit of something about the organism, like herring gulls like to eat, I bet you can guess, herring. So it's not their only source of food, but that's one they like. So river herring draw a lot of birds and other wildlife because they're food. They're food for a number of fish that we eat. They're food for birds. And in their juvenile size, which this would be when they've, just spending their first summer in the lakes or freshwater, wherever they happen to be, they're also food for things like frogs and turtles and a variety of organisms that we don't really think about. But I wanted to share with you the birds because the birds are awesome. And this is kind of gross and gruesome. Nature is not always kind, but everybody has to eat something. This is a herring gull that is snagging a river herring. So important to the food chain, and our ecosystem relies on everything having a place and some food. So it's amazing to me that the river herring, they're not big fish, but they're mighty big compared to herring gulls, and yet they're able to choke down a big river herring comparative to the size of the gull. Cormorants are other birds that we see a lot of during the herring run. They generally hang out in the water. They're great swimmers. They dive down. And again, the herrings seem too big for a cormorant to be able to choke down, but they are. These are black-crowned night herons, which are beautiful birds and also fish eaters. So we see these birds in numbers all throughout the watershed, excuse me, when the fish are running. So if you're not a fan of watching fish, and they're hard to see because they're in the water, you might be a fan of birds or of sort of food chains. And we do occasionally, and actually sometimes more than occasionally, see bald eagles who also are fish eaters, and the river herring are food for them. So really, this is an amazing ecological story. It's not just that the numbers of river herring are being restored, that people are thinking about ways to remove barriers so that the herring population can increase, except for last year, which is interesting to think about, but they are fueling populations of other organisms. And even if you don't think you like fish, or if you don't think you like birds, it's fascinating. It really is such a great connection. So on Earth Day, I'm going to encourage everybody to think about something they could do, sort of to acknowledge the importance of the wildlife that isn't us. So I guess that's all I'm going to say. I think our time might be almost up. Andy, I don't know if we have time to share the Great Blue Heron video, but if that were possible, that might be a great way to end. Muted.
This is another, just the Marion's reminder, the circle of life. This is a great blue heron at Upper Mystic Lake Dam, catching a herring that was at the bottom of the dam and swallowing it. And of course, they're alive when they're swallowed. And so it's still on its way down in this heron's neck, esophagus, and working its way to its stomach. But yeah, truly important part of the marine, freshwater, and kind of terrestrial ecosystems, are really an important species that connects all those spaces.
Oh, amazing. Thank you, Andy. That's my favorite video. Uh, so I guess we are just about at the end of time. I wanted to say, Magna, thank you so much for sharing that awesome video. I appreciate that you and your colleagues were able to, first of all, make that story sort of come to life in a different way, but also that you were willing to share it with us. So really thank you for that. I wanted to thank Elo behind the scenes for making all this work. Andy, thank you so much for helping me to know so much about river herring. And I guess I would like to thank all of you out there for knowing about river herring now. And hopefully you'll check out our website, count some herring for us, and just pay attention to what's out and about. So those are my final words. I don't know if Magna and Andy, you want to say a final word?
I don't think so, unless folks have questions. I can stick around for a few more minutes. But, yeah.
Great. I just want to thank everyone for engaging, and do feel free to join our kind of community science project at the mysticherring.org.
Okay, so if you have a final question, put it in there because Magna offered to answer it, which was great.
There was an interesting question in the chat about drought and its effect on different things. So like temperature, drought, all these things are things that will be affected by climate change. So one of my colleagues actually works on, Leanne Gua. She works on looking at how temperature increases will affect river herring growth to better understand how climate change is going to affect river herring. Bad news is it does seem like increased temperature does have a negative impact on river herring growth, although if there is enough food available, they can still survive. So so it is interesting to think about what drought will do, because drought results in higher water temperatures. It also results in different flow regimes and flow rates, which can affect all sorts of different things. So I thought that was a really great question. Yeah.
That is. I have a follow-up, Magna. So if temperatures impact river herring, does it impact the zooplankton? Do we know?
Yeah, it probably will. So it's it'll affect the zooplankton, it'll affect everything. So all this like timing stuff, because there's also a lot of really important matching up stuff where like if the river herring get there at the same time, the right time, but the zooplankton aren't really available yet. There's not what they want to eat. So there's a lot of unanswered questions. And so we're looking at growth rates, food availability, timing, all those things.
Right. Oh, interesting. Thank you. All right. Well, I think we are out of here. Thank you, everybody.
I know. Thank you.